At Kaizen, we know it's the science that makes the difference. The right solutions happen when you care enough to ask the right questions. And we understand that your performance is directly related to ours. Science knows why it works, care knows why it's important.
Welcome to the Metcal stand here at SMT AI. I'm joined by Kim Westy. Nice to see you, Kim.
Great to see you too.
Okay, so we're looking at your CV range of hand soldering irons here, but these are the ones that are sort of Industry 4.0 capable,
Correct.
Using intelligent tips. Talk us through a little bit how these intelligent tips work.
Absolutely. So the way the system works, it's all based upon induction heating, which has been the hallmark of Metcal for the last 35 years. What we've done is we've added a layer of power analytics to that system to allow us to, one, display a live temperature display on the screen without a temperature sensor, but also to give feedback to your operator when you have proper intermetallic formation or improper intermetallic formation in your solder joint. How it does that is a very simple four-step process. The first step is as you put the tip down, the power goes up and the system starts the calculation. If you then put a tip it then goes into preliminary validation. If you put a tip that is too small or too low of temperature onto a joint, the power is going to go up, but it's going to stay at some high level. So the system sees that, and within 2 to 4 seconds, if the power doesn't go down, you'll get a red light indicating that this tip will never create a good solder joint. If it passes that stage, then it'll go to liquidus detection. When the solder changes phase from solid to liquid, there's a brief blip in the power draw, and now we know how much time and thermal energy has been applied to the joint to reach liquidus. We can calculate how much more dwell time is needed to grow the intermetallic growth rates, because we know the growth rates of various intermetallics on various substrates. So what we've done now is we've begun expanding the offering of this. It began with point-to-point soldering, and now we've added a full complement of 3 soldering handpieces, 2 tweezer handpieces, and a desolder handpiece to make it a fully capable rework station as well.
Okay, so it's a full suite of different systems going from, as you say, from desoldering through to power devices.
Exactly.
So looking at this 4-step process, that essentially then creates like a mini profile that you then store in your data analytics against the reference number of the unit, so you'll know who has been using the unit at what time, and basically the different profiles that have been used.
Correct. About 30 different variables are captured on every single solder joint that you create. The part number, the tip, the part number and serial number of the tip, the date code, as well as what the starting power and starting temperature are, and the power and temperature of the tip every 100 milliseconds, allowing you to fully graph out that profile for your solder joint, which is typically only used in convection. So it gives you a thermal profile for your soldering joint to be able to optimize your process.
So taking a closer look at the actual inside the soldering tips themselves, here we are. You have a system here that shows the electrodes and the chip inside the barrel of the soldering iron. Can you talk us through what's in here?
Certainly, absolutely. So inside of every tip is a pure silver wire coil that is wrapped around a ferromagnetic alloy heater. So the basis of all of Metcal systems is induction heating. We call it smart heat, and it's a self-regulating induction heater. So when we apply that high frequency current to the silver coil, it induces current in the copper core of the heater. We take advantage of the skin effect, which forces that current out into the higher resistance magnetic layer, giving us a very rapid heat up. And then take advantage of another phenomenon called the Curie point, which is the point at which the magnetism will disappear. That becomes our regulation point. So we make 5 different alloys and 5 different temperatures. And that's how Metcal has worked for the last 35 years. By adding this double EEPROM chip, this memory chip, into the tips, we're able to store data on the tips for display on the system, but also create that traceability data that allows you to download that data either instantaneously by connecting it to a computer or at any point afterwards. Mm-hmm. These tips, in fact, are backwards compatible with all older Metcal MX series systems as well.
Looking at the range of tips that you've got here as well, you've got some quite novel new tips here. They've got a kind of V shape in the top of them. Can you tell us why that is?
Yeah, so what we found is that V-groove tips, as we call them, or notch tips, work extremely well for increasing thermal energy transfer to through-hole pins. By having a notch that fits around the pin, you can increase the effective surface area even without a thermal bridge and get a lot more thermal energy flowing into the joint. Anecdotally, we've had customers tell us that they're able to drop temperature almost 100 degrees with their tips when using these V-groove tips. So that's a new focus that we've begun, is expanding these V-grooved operations for different pin sizes and different tip sizes.
It's a great energy saving too. Great. Okay. Well, Kit, I want to say it's great to see you continuing to develop your system here with the CV range. Thank you for showing it to us today.
Thank you very much. Have a great day.